Welcome everybody. In this video, I want to discuss how to solve quadratic equations using the quadratic formula. So the nice thing about the quadratic formula is that it works for all cases. So if you have a quadratic equation, maybe you've tried other strategies already that are not really working well or they're getting to be too difficult, this one will always work as well. So the quadratic formula says the following. So first of all, you do have to have your quadratic equation written in this standard form where you have that equals 0 on one side and everything is in order. So that is really important that it is organized in this format. And if it is, then we can get the answers by just plugging it into this formula here. That's it. The most difficult thing though is that it is a bit tedious sometimes and it's very easy to make little silly mistakes. So you do want to be careful and watch out for those tiny errors as you're going through and just take your time with it. The other thing I want to point out is that this division bar is over the entire piece. It's not just over part of it. So that is important as well to remember that 2a is remaining in the denominator. When we say A, B, and C, we're referring to the numbers that are with each of those terms, right? So the A is the coefficient with the x squared term, the B is the coefficient with the x term, and the C is just the constant term. So let's look at an example. So here I have a quadratic, and I see that it is in the correct setup, right? I see that nice equals 0 there, and everything is organized square, then x, then number. So in this particular case, my A would be 3, my B is 16, and my C is 5. So what I'm going to do is take my formula and just plug them in. I have a negative here. The B is 16, plus or minus. My B is 16. I'm going to square it, minus the 4. My A is 3, and my C is 5. And then the denominator, I have 2 times A. So for myself, I'm not going to do any work first. I'm just going to plug everything in so I can see where it all goes. And then now I'm going to start simplifying. You do want to watch out. There is a negative in front of the B here. There's a minus sign inside as well. So these are where a lot of little mistakes happen. Okay, so let's start here. 16 squared, let's look at my notes, it's going to be 256. And then 4 times 3 is 12, times 5 is going to be 60. 2 times 3 is 6. Let's see, 256 minus 60 is going to be 196. And you can just use your calculator here. I have a lot of these numbers already done out for the video, but you're just using your calculator there. Notice that I'm just taking it one little step at a time. Next, I'm going to clean up that square root. It is really nice here because we do luck out in the square root of 196 is 14. Doesn't always work out that nicely. All right, now at this point, I'm going to start breaking into two pieces so I can keep simplifying. So one is going to have the plus sign there. And the other one's going to have the minus sign. Negative 16 plus 14 is 2. And then 2 over 6 can simplify to 1/3, right? Dividing those both by 2. Here, negative 16 minus 14 is going to be negative 30 over 6, which is negative 5. So my two answers here would be 1/3 and negative 5. Or if you want to write it as a set, you can write it like this, 1/3 comma negative 5 with those squiggly bars. And we're done. Now, I will tell you that when you have some pretty nicer answers, then this was a polynomial, or that could have been factored and solved via factoring as well. So some of these quadratics have more than one strategy that you can use. The nice thing about the quadratic formula is it does work for all quadratics. So if you're struggling or you're having a hard time, that you know that this strategy will always work. But again, a lot of these quadratics do have multiple strategies that could work. So it is sometimes fun to just try a couple of different strategies to make sure you get the same answer. Or if you're studying with a friend, again, each try a different strategy and you can compare your answers. So this is one where if you want to get a little bit more practice in, I would try this one by factoring. It will work in this particular example. And you'll see that your answers do match. Another strategy that does work with this one as well is completing the square. So sometimes there is more than one way to solve our examples. All right, here, so I do have to start by rearranging this. I do need to have an equals 0 on one side, so I'm going to subtract that 3 from both sides, and I get 2x squared minus 4x minus 3 is equal to 0. Now everything is in the correct order, right? I have my square term, my x term, and my constant. So my a here is 2, my b is -4, and my c is -3. Again, watch out for those negatives. The formula, if you need to, again, I do recommend having it with you somewhere on that page so that you're not constantly flipping back and forth, or putting it on a note card. And again, you can kind of just bring it with you as you are doing notes or doing homework problems. It looks like this. So I'm going to go ahead and plug in. Again, watch those negatives. I have a negative there, and my b term is also -4. My c is also negative. So again, lots to watch out for here. All right, my negatives there will cancel. I have +4. -4 squared is +16. Here, those two negatives will also cancel and be positive. I have 4 times 2 is 8 times 3 is 24. Let's see, 16 plus 24 is going to be 40. And again, now 40 is not a perfect square here, but I can definitely do more work with it. So 40 is the same thing as 4 times 10, right? And 4 is a perfect square. So I can break root 40 down into root 4 times root 10, or 2 root 10. Okay. Now I am going to go ahead and simplify this a little bit more here. There's a couple ways you can do it, but you do have to be careful. So one thing is you can leave it as a big group like this. And notice that 4, 2, and 4 all have a factor of 2 in common. So what you could do is you could divide out everything by 2 back here, and you're going to get an answer of 2 plus or minus. Now 2 divided by 2 is 1, and 1 times root 10 is still root 10. And you can write your, again, final answer this way. Okay. Or if you're struggling with that, what you could also do is you could break it down into 4 over 4 plus or minus 2 root 10 over 4. And 4 over 4 is 1. 2 over 4 is 1/2, so that becomes root 10 over 2. So you can simplify it that way as well. And then if you wanted to, you could also make the 1 2 over 2 if you wanted to get those common denominators and bring it back to this form here. But the big thing I want to point out is when you have these complicated expressions like this that have fractions, but you're also adding and subtracting, if you're going to simplify, it needs to come out of all parts. The other thing I want to point out is notice I did not touch the inside of the root. That is because outside numbers stay together for radicals, inside radical numbers stay together. So because these are all outside numbers, that's what I'm simplifying. I'm not touching that root 10 here. Sorry, guys. Make sure I put that on silent for next time. Okay, so here's another example, and this time you can see we're already started with the equals 0, which is great, but I have fractions. Now, you can work with fractions in your formula, but I don't recommend it. So what I would do is I would multiply through to cancel out those fractions first. The LCD we can use here is 4. My two denominators are 4 and 2. You could also use 8, of course, but we try to keep it as small as possible. So what you're going to do is you're going to multiply both sides by 4. And of course, make sure you're distributing that 4 to each piece. So before I do anything, again, my recommendation for everybody is to get rid of that fraction, of those fractions here. So in this case, the 4 over 4 will completely cancel, and you're just left with m squared. Here, there's nothing to cancel, so it's a minus 4m. Here, 4 over 2 is 2, so 2 times 1 is 2, and 4 times 0 is 0. So again, cancel that out before you start. It's going to make your life much, much easier in the end. So now I can start. My A here would be 1. If there's nothing there, there is a 1. My B is -4. And my C here, let's see, is going to be 2 in this case. All right, so let's start. I'm going to use the same formula that I did up here. So I'll just try to keep this all on the same screen. So I have a -4, -4 squared minus 4 times, let's see, 1, and then multiplied by 2. That's all under the root. The whole thing is over 2 times 1. And now I'm going to keep simplifying. So x is equal to 4 plus or minus. -4 squared is 16. 4 times 1 times 2 is 8. So this is a -8 all over 2. And of course, 16 minus 8 is going to be 8. Now, again, I would take that time and do that work off to the side. 8 is the same thing as 4 times 2. So I can break this root down into 2 root 2. And I have 4 plus or minus 2 root 2 all over 2. Now I'm going to leave this as one big fraction. I am going to simplify. Remember, when you're simplifying with outside numbers like this, ignore the radical. Just leave it alone. So I have a 4, a 2, and a 2. The one thing that goes into all of those numbers is 2. So I'm going to divide these each by 2 here. That leaves me with 2 plus or minus. Now, 1 times root 2 is just root 2. And in the denominator, you technically have a 1, but we don't need that denominator. So I can rewrite this as just 2 plus and minus root 2. So I have two answers, 2 plus root 2 and 2 minus root 2. And those would be my two solutions for this equation. So when you see, again, those fractions, again, you can work with them in the formula. It doesn't matter, but I highly recommend you clear those out. And then it'll make your life a little much easier as you're going through. Now, there are a ton of applications with quadratics as well. One of those applications that we can use, and it relates directly to the quadratic formula here, is called the discriminant. So the discriminant of a quadratic equation is just that piece under the radical. So if you go back to the formula here, so I rewrote it right here. So see that piece under the radical, b squared minus 4ac. We call that the discriminant. And the reason why it's so important is because it actually tells us what's going to happen with the solutions. When that discriminant is positive, which actually happened in all of our examples, you will notice that we had two real solutions. Your discriminant could be 0, though. When that happens, when that discriminant is 0, I'm going to go back to the formula again here. This piece becomes 0, so you lose that plus or minus idea, because plus or minus 0 is still 0. So you end up with only one unique solution there. And then the last case is if that was negative, then your two answers would actually be imaginary. So that would be a topic for another lesson. But if it's negative, then they would be imaginary. So you would have still answers, but they're not real solutions here. So just to do an example of this. So here's your equation. It still has to be set up in the correct order with that equals 0. So our A is 1 here, our B is 2, and our C is 1. So if I look at the discriminant, that b squared minus 4ac, I would have 2 squared minus 4 times 1 times 1. 2 squared is 4, and 4 times 1 times 1 is also 4. So the answer is 0 here. So what I would expect, because my discriminant is 0, is that I would have only one real solution to this problem. And if you're not sure, you can go ahead and try the full thing out, and I'll just do it very quickly. So you'd end up with -2 plus or minus. Again, we already saw that b squared minus 4ac is going to be 0. So I'm going to kind of skip this piece here over 2 times 1. So you have -2 plus or minus root 0 over 2. Now, root 0 is just 0. So adding and subtracting with 0 is not going to affect anything here. So this ends up just being -2 over 2, which is -1. So when your discriminant is 0, you have only one solution. As the other examples we saw, if we kind of go back through our notes a little bit, here the discriminant was 40, which is positive, and you can see I had two answers because of that plus or minus. Or down here, my discriminant was 8, or I can simplify more, but 8. And then again, I had two answers. So that discriminant really tells us a lot about these problems. All right, so the last example I want to do in this video is just one word problem example. There are so many word problem examples that we can do with quadratics. So this is just one of them. But a lot of our word problem examples, as a heads up, may not be factorable or easy to solve. So the quadratic formula can really help if you have a word problem example that is not factoring and you're kind of getting stuck on it. The quadratic formula can help you solve it. So this says an object is thrown upward from the top of a 200-foot cliff with a velocity of 12 feet per second. The height h in feet of the object after t seconds is given by this formula here. So h is your height and t is in seconds. How long after the object is thrown will it strike the ground? So let's kind of make a picture here. So let's say we're at the top of this kind of cliff, and maybe there's like a valley or something below. And we're standing up here, and we're going to throw this object up into the air. So it's going to go up a little bit first, and then eventually it's going to come down, and it's going to hit the ground, right? So our question is, how long will it take for the object to strike the ground? Now, ground level, by the way, is when your height is 0 feet. Now, this could change if you're below sea level or something like that. But again, it's pretty standard for us to say ground level is height 0. If that's different than the problem would say it. But otherwise, we assume that ground level would be height 0. So what we're going to do is replace the h with 0 here. And you can see that I'm already in that equals 0 form, which is really nice if I'm going to use the quadratic formula. I'm going to use the quadratic formula here because I really don't want to have to think about trying to factor things like 212 and 16. That 200 is really, really big there, right? So I'm going to not try to factor this. I'm going to try to just use the quadratic formula. So my A here would be negative 16, my B is 12, and my C is 200. All right, so if you need to go back to the formula, go back and review it, but it's negative B, so negative 12, plus or minus B squared, so 12 squared, minus 4 times A times C, and that's all over 2A. All right, let's do a little bit of simplifying here. On the inside, you end up with let me get out my calculator for a second. Oh, there's my Griffey coming to see you guys. All right, let's keep going now. So here, 12 squared is going to be 144. Negative 4 times negative 16 will give us a positive. And then 4 times 16 times 200 is 12,800. And this whole thing is over negative 32. When I simplify inside the radical and I add those two values together, I get 12,944 all over negative 32. Now, I'm not going to worry about trying to simplify 12,944 here. A lot of times our word problems, we're okay with decimal answers anyway, because they make more sense sometimes in the real world. So I am going to keep going, though, and split into two values. So it's negative 12 plus the square root of 1,209.44 all over negative 32. So that's option 1. Or my second solution has the negative sign in it, right? The minus sign. Now I am going to go ahead and put these into my calculator, and I want to see what happens here. So first I have negative 12 plus the square root of 12,944. That gives me positive 101 about. And then I divide that by negative 32, and I get about negative 3.18. In the second case, I have negative 12 minus the square root of 12,944. So about negative 125, 126 divided by negative 32, and I have about 3.93. Now let's take a look at that problem again. Remember that first of all, t was in seconds. So my answers here are in seconds. And if I look at my two answers, the first one just doesn't make sense, right? If I'm throwing an object off a cliff, it's not going to happen in negative 3.18 seconds. That just doesn't make sense. So the first answer must not be relevant for this particular problem. So the second answer would be the one that I'm looking for. So it's almost 4 seconds for that object to hit the ground. So here is our exact answer, and here is our estimated answer. Now, as a little side note here, some students may have noticed that these numbers are all divisible by 4 to start. So you could have also divided everything by 4 to start as another way to kind of clean this up a little bit. But if you're approximating with a decimal, it's not going to matter in the end. So sometimes there is more than one way to do this. Again, if you see some way that you can clean up a problem at the beginning, like we did with the fractions in the last case, or here by dividing everything by 4, then you could do that to make it a little bit simpler to start. For this one, I knew I was going to use a decimal answer, so I left the larger numbers. But it's just great to keep in mind that there is sometimes more than one way that you can do something. So here's our video on the quadratic formula. It's a really great formula. It works well with those really complicated quadratics that we just cannot factor or find an easier way to solve with, like with the square root property or something like that. It is a nice formula. You have to watch out for little mistakes, particularly with negatives and arithmetic, and making sure to clean it up correctly at the end. But it does come in handy, again, particularly for word problems, which tend to be messier as well.